Another element of concept 4 that we need to be able to do is to read a word problem, translate that word problem into a system of two inequations, and then be able to solve for the designated variable. So let's start by reading this question and seeing how the system itself is supposed to kind of emerge. We're reading the question, realizing that she's selling two different types of items at a yard sale. Books for $2, records for $4. So those must be our two variables, books and records. She sold 55 total items for a total of $120 profit. And we want to know how many books she sold. So since we have two variables, let's write our two equations. Now before we write, the best way to kind of approach this writing process is to use what we usually call active reading. You might have heard of that in an English class a long time ago. Active reading is when we circle or highlight or underline any of the important information that we know we're going to need. For instance, we know that $2 was important. That was the profit for books. The $4 was important. That's the profit for records. 55 is the total number of items that we needed to sell. And 120 was the total amount of profit that we were going to make. So by the time we look at all of those all of those items, we need to then kind of figure out which ones belong together. For instance, if you look carefully, 2 is a number of dollars, 4 is a number of dollars, 120 is a number of dollars, which means we have some common units, dollars, dollars, and dollars. And those common units should always go together in the same equation. So if we read and synthesize, we know that it costs $2 for an old book, $4 for an old record, and a total of $120. So if we translate that into an equation, the general structure should be 2b plus 4r equals 120. The number of dollars for books plus the number of dollars for records equals the total number of dollars. By writing that equation, 2b plus 4r equals 120, we've used up 3 of the bits of information we were given, which means the only bit of information we have left is that 55. Now, we don't know anything about the 55, just that it's the number of total items. But if we know that B and R represent the different types of items, we can write a second equation as B plus R equals 55. Noticing that the items for book plus the items for record would have to equal 55 total items. Similar structure to the first one. Now the question itself is going to ask us how many books we sold. So in looking at the system of equations we wrote, we need to try to figure out how to solve for B. Now, if you recall from when we went over the first question in this set of videos, we talked about 3 different methods we could use to solve this system. The methods were substitution, combination, or graphing. So let's think of our 3 methods and think about which one would be most appropriate here. Substitution was the one that we used when we had a variable by itself, like R equals or B equals. But if we look at our equations, we don't have that structure here. So substitution is probably not a very good call. Combination is the method we used when we have our variables lined up vertically. We can kind of see that we have that working here. The B's are lined up, the R's are lined up, the equals lined up, and the numbers lined up. So it seems like combination is going to be a good bet. But let's just triple check our third method. The graphing method is useful when everything is in y equals mx plus b form, the numbers are reasonable to graph, and we can make a quick sketch. Unfortunately, 120 is a pretty big number to graph, so is 55. So because graphing just might not be practical, we're not going to use that one. We're going to stick with combination, which is the vertical method of getting rid of a variable or eliminating a variable. The easiest variable to eliminate usually depends on what you're trying to solve for. So since we want to solve for books, B, we should try to eliminate the other variable, in this case the R. If we want to try to eliminate those R's, that means we need to have a common number that we can use to create an opposite. For instance, positive 4R can only cancel something that says negative 4R. The nice thing is we're allowed to make changes. We can make the bottom a negative 4R as long as we multiply the entire equation by that same number. So if we need to multiply by negative 4 to create the opposite that we need, that just means the whole row is going to multiply by negative 4. That turns this into negative 4b minus 4r equals negative 220. It's like the distributive property. Now the top row we didn't need to change because the r was already set up there. So we're going to keep it as 2b plus 4r equals 120. Now we have a set of opposites, the 4r minus 4r. So when we combine like terms vertically, those are going to cancel out. Then we simply combine the rest of our like terms, still vertically. 2b minus 4b is negative 2b. Equal sign comes down. 120 minus 220 is negative 100. To solve for b, we'll need to divide by that negative 2. And that means that b must be equal to negative 100 divided by negative 2, which would be positive 50. Now, we can be almost sure that we're correct, but the only way that we'll know for an absolute fact that we're right is if we double check with the rest of the problem and make sure all these figures add up. So let's just go back for a second and use that information to help us check. If b is indeed 50, then that means we sold 50 books, which forces us to have sold 5 records because we know she sold 55 items. If she sold 50 books at a price of $2 a piece, that means she made $100 on books. If she sold 5 records for a price of $4 a piece, that means she made $20 on records. And if we look carefully, that would mean she sold a total of $120, which is what we needed. She sold a total of 55 items, which is what we needed. So we know we solved correctly, and we verified it. So she sold 50 books, and even though we weren't asked for it, 5 records.